So the next session is about something we added recently in the OpenIO product, which is metadata indexing with what we call Great for Apps. And so in this session, I will present what is Great for Apps and how we use it to do indexing of metadata in OpenIO, and especially how you can benefit from such feature inside your OpenIO cluster, and how easy it is to use. So let's get started. So first of all, I want to discuss and present you a bit of what is Great for Apps. So you may have heard of it since this morning talk. So you may have heard serverless environment computing, something like this. And for those familiar with serverless functions, it's very similar actually to what Amazon provide in the product called Lambda. So I don't know if any user of Lambda is present. Nobody uses. Is anybody using such serverless platform? Okay, so let's try to explain what it is. So what are great functions? So first point is it's serverless. What serverless really means is you don't really manage the hardware, of course, and you really don't manage the host. So you don't really know where the code is running. You don't really care from the developer perspective. You just ask the system, please run my code somewhere and try to scale it automatically. That's the main idea behind serverless is you don't really want to care with the OS updates, the firewalls, the IP setup, the configuration. You just want to run your code and that's it. And that's really what great functions provide on your own cluster compared to what Amazon provides, but it's running in their machine. So number two is event processing. What is really behind the event processing idea is, as you may know, in OpenIO SDS, so the storage part, there is events that happen when you create an object, for example, when you create a new container, or when you change some metadata, or you add like a new account. And in this situation, there is some events that you can listen to and then process. And Great Function lets you do this very quickly and very easily for OpenIO. So Great Functions is also something that you can use to extend services and by doing microservices. Microservices are really like a few lines of code that you want to run. Maybe each time a new object is created, maybe you want to check if it's like a large file that you want to compress. I don't know. And this is very simple code that you want to maybe write yourself with your own tools that you already have. And Great Functions let you do this, so you don't have to ask anybody from OpenIO to implement your compression system. You just use the Great Functions, add your own code, and run it, which is really, really, really good for testing and trying new stuff inside your storage. So main features of OpenIO, Great for Apps and Great Functions especially, is so you deploy your code. So really, you just provide your code and you let the system do all the rest. So the system will schedule where the code will actually run inside your cluster. So imagine you have already a cluster of 10 nodes, and you don't really care where I want to put it on, I don't know, server 1 or server 2. You don't really want to choose, and you don't really want to maintain this. Just want to be available sometimes. And that's really what green functions lets you do. You just declare, I want to run this code, and the system will make it happen. It's self-healing in that sense that if your code crash, that can happen for many reasons, we will restart it, and maybe if the node entirely crash, we migrate all the functions from this node to another node. So you don't really have to care about, is my function really running because this server crashed, or this server is in maintenance. The system will do it for you. And you have logging and metrics out of the box, so you don't have to implement a new logging and metric stack for your code. And it's open in that sense. You can use today's languages. You don't have to learn new framework. So for example, if people here are familiar with MapReduce kind of jobs systems like Hadoop, or you usually have to learn a new language, new tools, and code in a certain way. With the grid function, you don't have to. You can use your existing code, that your existing bash script even that you're running inside your cluster, maybe with a cron tab or something very old school, and you can run it inside grid functions. This makes it very easy to test with. So what are the real use case for this? First of all, first one is, data processing. So imagine you store logs, emails inside your platform, and you want to index them. You want to make sure this data is, well formatted. You want to detect some kind of fraud and find some patterns inside documents. This is something that grid function lets you do very easily. You write your code on your laptop, you let your developer do it, and then you push the code to the cluster, and it's running for all your objects when there's new objects coming. AI is a big topic as well. All the machine learning code can also be used. So if you want to recognize some image, I want to add tags to this image after you save it, automatically you let your cluster intelligently recognize all your images you store in your platform. IoT, so IoT is more about, you have thousands of IoT devices and they're pushing all the time metrics, and you can make functions react to these IoT events, which is something which is really cool if you combine it with the object storage, because, for example, you receive 1 hour of metrics from a temp sensor, and you have all this data, and what you want to do it is usually you want to save it to the object store to archive it. And with grid function, it's very easy to do it. Integration, if you want to integrate with existing system or other cloud services, let's say you want to integrate with another object storage system, like the one from Amazon, the one from Google. They usually provide some ways to do webhooks or event system. And you can plug your object storage, OpenIO object storage cluster with functions like this. This is an example of a webhook system. This one is really, really simple. This is a Slack command that is accessing the GitHub API. So this is using Python for the developers who can understand this piece of code. And it's really the only code you need to do your function. So there is no OpenIO specific code here. It's really plain old Python. Another example I can show is, for example, image processing. So let's say you want to process image. So maybe you recognize very famous movie. And so there is the image coming from the user, for example, is saving it from his phone. You analyze it, you identify contents, and then you transform and save results. That's a very classic workflow that is definitely very easy to implement with functions. So now let's talk about metadata and in OpenIO. So in OpenIO there is, as you know, containers and objects have metadata attached. So there's the size, for example. This is a very basic metadata, and there's the MIME type, content type, and there's the name of it, the object, and then you can add your own. And usually some users, they ask us, I want to be able to search inside my cluster very fast without even accessing the object storage, and they need something like Elasticsearch. And that's really what we provide here. And how we do it. So it's real-time indexing. So every time there is a new storage event, so new content, for example, we extract the metadata and we push it inside Elasticsearch using Grid4Apps functions. So you have the flexibility of OpenIO and the power of Elasticsearch inside the same environment. And that lets you build very intelligent applications, I think. If you combine it with maybe machine learning stuff, makes it very powerful. Main features is, of course, it indexes real-time, so event-based. So you push it, and 1 second after, you can already search and look your new content. You can provide and customize your mapping. So in Elasticsearch, there is ways to search some data that is optimized. If you know this meta is, for example, an IP, if it's geolocation mapping, you can ask Elasticsearch to recognize it as well. This is something we provide. And yeah, you search all your account very easily. And there is auth system. So most users, they use S3 to access their data. So they push using S3 credentials. And what we provide with this new feature is you can access your Elasticsearch index using the same S3 credentials. So you're sure that people who are searching the index, they have the rights to do so. And all of this is implemented using functions. So if we have some time, I can do a quick demo, and then we go for the questions part. So I have a small cluster running inside Google Cloud for the sake of today's presentation. So course. So if you know the OpenIO CLI, there's nothing very new here. So I have 2 buckets, 2 containers here. I have a basic 3 nodes cluster from OpenIO. Everything is, well, as usual. And we added Grid4Apps. So let me show you first I will add a new object. For example, this magic file, always create the magic file. Let's change it. Let's use something else, like, yeah, okay. So I did my file. So what happens now is OpenIO creates an event for this, and they will trigger the Grid4Apps functions that will index it. How we check this? So I have a memo here. So if you know Elasticsearch API, this is just asking Elasticsearch, please search inside the index. So the name here is the name of the index. It's a bit weird like this. It's actually encoded because in OpenIO accounts, you can make all the characters you want. All the characters are allowed. In Elasticsearch, that's not the case. You have only alphanumeric call and no caps. So we had to change it a bit. And let's search it. So here it is. So I have two files. This one I already created before. It's the magic file. And this is the one I just created, so OS release. So all the field you see here is fields coming from OpenIO. So the ID of an object, the size, the count name, the container, the name, the hash, creation time, etc. So that lets you, for example, imagine I have like 2 million files. I want to say, okay, please find, in all the account, please find very small files like 1 byte file. And with Elasticsearch, you just do a similar command and it searches you in a few milliseconds, the results. And then you can access the actual data inside OpenIO SDS. So, I don't know. It's maybe not very impressive to look at it like this, but I think it's very cool to have this kind of feature inside the object storage. And I can show you how does it look like in the Grid4Apps part. So let's do the same here. And let's go for the Grid4Apps. So this is a new CLI that we added for the Grid4Apps. So it lets you check my function. So here I have two functions deployed, one called indexing and one called search. The indexing is really the one who will receive events from OpenIO, and it will interact with Elasticsearch to index your data properly, and we'll handle the mapping and everything. The search is if you want to access the cluster index using S3 credentials. So it do the authentication system. And all of these are just functions. And you can access, for example, I want to access my logs for this function. So just do something like this. My function is called indexing. And here it is. So maybe I can make it nicer. So it's JSON, it's very standard stuff. But you see, this is the event I got from OpenIO. Content new, so new content. And this is the name of the account, and this is the name of the object, container, and name of the object that was created. And you can follow like this all the new index using the Grid4Apps. Something that is interesting with this is, let's say, here I have, whoops. So here it says ready one. What that means is there's currently one worker running the indexing. Could be fine for this cluster. Maybe if you have thousands of objects per second, one worker is not enough, and you want to scale it. And you will have to scale it. And how do you scale? Well, it's easy. You just do something like this. So it's I want two, please deploy another one. And yeah, that's it. So I have now 2 workers running. So it shows you how easy it is to add some kind of intelligent features to the object storage part. And at the same time, don't really bother with how we deploy and how we scale it, because the system will do it for you.